In this video, we'll learn about how we are going to form the bus admittance matrix using MATLAB. So before going to do the practical demonstration, now let us discuss about, first of all, the theoretical explanation of how we are going to form the bus admittance matrix using direct inspection method. So for that reason, first of all, we require a power system network consisting of three buses. So bus number 1, bus number 2, and bus number 3. So we have three transmission lines. One transmission line is connected between bus 1 and 2 having impedance value of 0.15 plus j 0.6. And another transmission line is connected between bus 1 and 3 having impedance value of 0.1 plus j 0.4. Another transmission line is connected between bus 2 and 3 having impedance of 0.05 plus j 0.2. So these all impedance values are in actual values, nothing but in terms of ohms. So in order to form the Y-bus, first of all look into the direct inspection method formula. So Y-bus consists of two elements. One is diagonal elements, another one is mutual elements. So how we are going to calculate the diagonal values and how we are going to calculate the off-diagonal values, now let us check. Okay. So in order to find out the diagonal elements, so this is the formula, that is capital YII is equal to sigma small yij. I is also a bus number and j is also a bus number from 1 to n. So in order to find out the off-diagonal elements, capital Yij is equal to minus small yij. I is also a bus number and j is also a bus number from 1 to n. Having n indicates the number of buses. So here we have two y values. Small y indicates the transmission and admittance, and capital Y indicates the element of the bus admittance matrix. I repeat, capital Y indicates the elements of the bus admittance matrix. Small y indicates the transmission line admittance. Okay, so now let us form the Y-bus using direct inspection method. So first of all, we'll write down how actually the Y-bus, what are the elements the Y-bus contains with. So Y-bus is equal to, we require in this Y-bus capital Y11, capital Y12, capital Y13. So why it is a 3x3 system? Because the power system network consisting of three buses. If it is consisting of three buses, then it is a 3x3 system. If it is consisting with two buses, then it will be 2x2 system. So Y21, Y22, Y23, Y31, Y32, Y33. So you can write this is bus 1, bus number 1, 2, 3. This is also bus number 1, 2, 3. So our objective is we need to find out these elements. If you have successfully find out these elements, that means we have completed the formation of Y-bus. So now let us check how we are going to find out these elements. So first of all, the diagonal elements. So in order to move directly to the diagonal elements, the given power system network is actually in terms of impedance values. So we will try to convert the impedance values into an admittance values. So what is here? So we require Y12. So what is Y12? Small y12 is equal to 1 divided by Z12. So what is Z12 here? So Z12 in this is 0.15 plus G 0.6. Okay. So that means 1 divided by 0.15 plus J 0.6. So if we calculate the respective value, we are going to get 0.392 minus J 1.56. So this is about Y12. Similarly, if you want to calculate Y13, which it is reciprocal to Z13. So what is the Z13 value? Z13 is, just go to the power system network. Z13 is 0.1 plus J 0.4. So 0.1 plus J 0.4. So is equal to, what is the respective admittance value? 0.588 minus J 2.35. So similarly, calculate the another admittance value of the transmission line, that is Y1 divided by Z23, which it is inversely proportional to the Z23 impedance. So what is the value of Z23? The Z23 is The impedance which is connected between bus 2 and 3, that is 0.05 plus j 0.2. That means 0.05 plus j 0.2. So what is this? Admittance value is 1.176 minus j 4.70. So these are the three admittance elements of the transmission lines. That is, this is admittance value of a transmission line 1, this is an admittance value of transmission line 2, this is an admittance value of the transmission line 3. So we have three transmission lines. So from the three transmission lines, we have calculated the three admittance values. So now let us calculate the diagonal and off diagonal elements. So first of all, we'll try to calculate the diagonal elements. So first, diagonal elements. So how many diagonal elements are there in the Y bus? So in Y bus, we have three diagonal elements because it is a 3 by 3 system. So these all three are nothing but the diagonal elements. So remaining all will be the off diagonal elements. So remaining all will be the off diagonal elements. Okay. So that means we need to calculate first of all capital Y11. So what is from the formula what we have seen in the diagonal elements? What is capital Y11? So is nothing but the elements which are connected to the respective bus. So we are calculating at bus number 1 means, so what are the elements connected to the bus number 1 from the power system network? We have two elements connected at bus number 1. So one is this element, this transmission line, and another one is this transmission line. So addition of this summation indicates an addition. So addition of this transmission line admittances will give you capital Y11. Okay. So this is going to say that one only. Okay. So addition of the values which are connected to that respective transmission, to that respective bus. That means Y12 plus Y13. So what is Y12 from the answers? We have calculated Y12 is 0.392 minus J1.56. Okay. Plus what is Y13? 0.588 minus J2.35. So what is this resultant value is? Resultant value is 0.98 minus J 3.91. So which it will be in terms of mhos. Okay, I'm not representing units. Okay. So next, similarly calculate, this is at bus number 1. So this is at bus 1. Similarly calculate at bus 2, that means capital Y22. So what is capital Y22? The elements which are connected to bus number 2. How many elements are connected to bus number 2? 21 and 23. Therefore, Y21 plus Y23. So what is the value of Y21? Y21 is also equal to Y12. Therefore, it is 0.392 minus J1.56. But what is the admittance value of Y23? Y23 admittance value is this one, 1.176 minus J4.70. Okay. So this resultant value is we are going to get as 1.568 minus J6.26. So this is the way how we are going to calculate the diagonal element of bus number 2. So coming to bus number 3, bus 3, that means capital Y33 is equal to, so the elements which are connected at bus number 3, that means Y13 and plus Y23. If you see clearly, if it is 1 1, then 1 will be common in every element. If it is 2 2, then 2 will be common. If it is 3 3, then 3 will be common. Okay. So by that also, by using this procedure also we can find, are we doing in a right procedure or not. Okay. What is Y13? Y13 is 0.588 minus J2.35. What is Y23? 1.176 minus J4.70. Okay. So what is this value we are going to get? The resultant value is 1.764 minus J7.05. Okay, so this is the way how we are going to calculate the diagonal elements at bus 1, bus 2, bus 3. That means capital Y1 1, capital Y2 2, capital Y3 3. So diagonal elements calculation is completed. I think it is clear. Now let us discuss about the off diagonal elements. So off diagonal elements, nothing but mutual elements. Off diagonal elements. So in order to calculate the off diagonal elements, we are going to use the formula of the off diagonal. So what is the formula? So this one. So if it is capital Y12, then it is minus of small y12. That's it. So just it is the minus value will give you the impedance, the admittance element. That means if I at bus number 1, at bus 1, so what are the values we are left with? Capital Y12. Capital Y12 is minus small y12. Okay. So what is minus small y12? What is y12? Y12 is, so if you substitute, that means 0.392 minus j 1.56. So therefore, this is equal to minus 0.392 plus j 1.56. So this y12. Okay. So what if we have left? Capital Y13 is minus small y13. I'm writing directly the value as minus 0.588 plus j 2.35. So this is under bus 1. So under bus 2, what we need to calculate? Y21. So Y21 is also equal to capital Y12. Okay. So which it is already represented here. And Y23, capital Y23 is minus small y23. So which is equal to minus 1.176 plus j 4.70, which we have already know this y23 value. So these are the elements under bus number 2. Similarly, calculate the elements under bus number 3. So under bus 3, so y13. So capital Y13 is nothing but capital Y3. Sorry, capital Y31 is nothing but capital Y13 itself. Both are same. Y23 is nothing but sorry, we should need to write 3 first. Capital Y32 is nothing but capital Y23. So these all values we already know from the previous calculations. So now we know all the bus elements. That means we know the diagonal elements, we know off diagonal elements also from this. Now let us form the Y bus by including all these values in those respective places. So what is Y bus? Y bus is equal to, so what is Y11? Y11 is, just I will write Y11, Y12, Y13, Y21, Y22, Y23, Y31, Y32, Y33. This is 3 by 3 matrix. So this indicates bus 1, 2, 3. This is bus number 1, bus number 2, and bus number 3. Okay. So always represent elements under the bus Y bus matrix as capital. Don't represent with the small letters. Small letters indicates the transmission and admittance, but not the Y bus elements. Okay. So now what is Y bus now? So Y bus is equal to, just write their values in those respective places. So what is capital Y11? Capital Y11 indicates 0.98 minus j 3.91. Next, capital Y22, capital Y12 indicates minus 0.392 plus j 1.56. Capital Y13 indicates minus 0.588 minus j 2.35. So it is plus j 2.35. Next, capital Y21 indicates minus 0.392 plus J 1.56. Capital Y22 indicates 1.568 minus J 6.26. Capital Y23 indicates minus 1.16 plus J 4.70. Capital Y31 indicates minus 0.588 plus J 2.35, the same value of Y31, Y13. And Y33 is also equal to Y23, that is minus 1.176 plus J 4.70. Y33 indicates 1.764 minus J 7.05. So this is the bus admittance matrix. Bus number 1, bus number 2, and bus number 3. So this is the bus admittance matrix. Okay. So this is the way how we are going to calculate theoretically the bus admittance matrix using direct inspection method. Now let us verify this result using MATLAB. So we will start writing a program. So for that, in order to write the program, open MATLAB software. And go to new script. So what I have already done is I have written the line data. So if you see here, so this is clear. Okay. So this is clear. So whatever the data is there, the data will get cleared. Then after this, if you are writing anything in front, as if you are starting with a percentage, that line will not be counted as the new counted as in the program. Okay. So that line will not be counted. So you can write anything. Before that, you need to write as a percentage. Okay. So percentage. So bus NL, bus NR, R in terms of per unit, X in terms of per unit, susceptance in terms of per unit is equal to 1 for lines, greater than 1 or less than 1 for percentage tapping, that is transformer tapping. Okay. If you want to represent in terms of per unit, you can write down. Indicates X per unit also you can write down. If it is actual value or per unit value, no problem, because these are only the percentage values. Okay. So now what you need to do? So enter line data is equal to start writing representing the line data in terms of brackets. Okay. So NL indicates the first that is the starting bus. For example, here if you go to the power system network, as per the power system network, you need to represent that one. You need to write down that line data. So that is only the input what we have. So this is the input. So this one will be your NN, that starting point and ending point. The starting point will be 1, ending point will be 2. So what is the impedance? Okay. See here, starting point is 1, ending point is 2. What is the impedance? How much is the impedance? We have, here 0.15 plus J 0.6. This indicates resistance, this indicates reactance. Same thing, 0.15 is the resistance, 0.6 is the reactance. So it doesn't contain any susceptance, so it is 0. It also doesn't contain any transformer, therefore it is 1. If there is a transformer, then there will be change in the value. If it is a step up, then it will be more than 1. If it is a step down, then it will be less than 1. Okay. Now coming to another line. So for one transmission line, it is completed. So this complete includes the information related to a transmission line 1. So we have not only one transmission line, but in the power system network, we have 3 transmission lines. So we need to represent also the similar data for transmission line 2 and transmission line 3. So from 1 to 3, so what is the data here? We have 0.1 plus J 0.4. So resistance is 0.1, reactance is 0.4, no susceptance, and transformer, we don't have any transformer there. So next, bus 2 to bus 3, there is a resistance 0.05 and reactance 0.2, no susceptance and no transformer. Okay. So 0.05 plus J 0.2. So this is the way how we are going to write down the input data, how we are going to put our input data in terms of line data. Then after, close the bracket and give a semicolon. So this complete thing is nothing but input data, what we require or what we are going to give from the power system network. Now start writing the program for fibrous formation. So how we are going to start writing the program for a fibrous formation is nothing but we need to start a program. So by typing percentage this program obtains the bus admittance. Write down the program. This program obtains the bus admittance matrix. So first we will start with representation of j, because anyway we are going to use some j like that. So first we will write j. What is j indicate? J is nothing but square root of -1, okay, and give a semicolon. If you want, you can also write I is equal to square root of -1, give a semicolon. So wherever we have a concept of j, then it is going to take the value of square root of -1. If we have any I, it is going to take it will take the value of square root of -1. Okay. So simply we can write j. So what is actually we need to write down what is this NL NR represents. So NL. So NL is equal to, so NL is the first column of the line data. So in order to write down that one, you need to write line data in the brackets and colon next comma 1. So this indicates it is going to take the first column of the line data, which we are going to call it as NL. Okay. Give a semicolon. Now similarly NR. So NR is the second column of the line data. So NR is equal to line data colon comma 2, which is the second column of the line data. Similarly, what is the resistance here? Capital R is equal to line data colon comma 3. So it indicates the third column of the line data is the resistance in terms of unit. If you want to write in capitals, you can write. Small letters also you can write. So next, reactance. How we are going to write down the reactance? So that means X is equal to line data colon comma 4. Indicates the reactance. Write it as BC. Susceptance is equal to line data colon comma give a semicolon. So this indicates the susceptance. So in this case, there is no susceptance available, but if there is any susceptance available for any power system network, so this will work out. Okay. Next, transformation ratio will represent with small a is equal to line data colon comma 5. So these are the six inputs what we are going to give from the line data. So NL indicates the line data, NL indicates the first column, NR indicates the second column, the third column indicates the resistance, the fourth column indicates the reactance, the fifth column indicates the susceptance, the sixth column indicates the transmission line transformer ratio. After that, we need to mention what is the length of a transmission line. Length of a transmission line means how many transmission lines are there. That means NBR indicates the length or the data or how many number of transmission lines are available. Okay. Is length of line data. So what is the length of a line data? So if you want, you can do only for NL. So that will be enough, or it is going to give a colon comma, how much is, give a semicolon. So this NBR indicates is so this NBR indicates how much is the how many number of transmission lines are available. See, it is going to calculate of the first column. So what is the length? 1, 2, 3. That indicates the power system network having 3 transmission lines. For example, if you have another transmission line, then it is going to calculate 1, 2, 3, have any another transmission line. So this is the way how we are going to calculate the length or how many number of transmission lines are there. Okay. So we are missing with one another bracket. So this is closed. Now it is okay. So what is the next one? We need to calculate. Next we need to calculate the inverse. So calculate the inverse. So we have missed also another one. Okay. So calculate inverse. So how many brackets we have here? 1, 2, 3 open brackets. So 3 closed brackets. Okay. So it is going to show you an error if you are not giving the all closed brackets. So inverse is equal to maximum of NL comma NR. So it is going to calculate what is the maximum bus number the power system network is having. So you can write max of NL. What is max of NL in this case? 2, comma, max of, what is the maximum of NR is 3, and then close brackets, semicolon. Okay. That means it is going to calculate first of all the maximum of NL. So what is the maximum of NL? That is the first column. In the first column, maximum value is 2. Okay. So what is the maximum NR? NR is the second column, 1. So what is the maximum value is 3. That means it will decide that the power system network contains 3 buses. Have 4 any digit, that indicates it consists with 4 buses. Okay. So next we have given everything information, and then after we need to calculate the impedance. Then after we'll calculate the admittance. So what is the formula of impedance? Capital Z is equal to, we already know it is R plus Jx. So how we have represented here, you need to give the same thing, R so we need to write it here as J multiplied with X. So this is the way how we are going to calculate the impedance of each transmission. After calculate impedance of each transmission line, Y is equal to, write it as ones, all the ones, and how many transmission lines are there? That is NBR. After we require 1 by Z, so dot by. So this is going to calculate each and every transmission line admittance. So this one is going to calculate each and every transmission line impedance. It is going to calculate each and every transmission line. In order to form the bus admittance matrix, we require not impedance but admittance values. So this is about the branch admittance. You can write here as, because we are writing by using the percentile, so this will not affect the program. We need to start. So whatever the data we have given, we have named those data by using this NL, NR, capital R, X, B, susceptance, is the size, how many number of buses are there, what is the admittance value of each element also we have done. Now we need to form the diagonal elements first. So formation of diagonal elements. So we need to first of all formation of diagonal elements. How we are going to form formation of diagonal elements? So how we are going to form? First of all, we need to take a for loop. For example, if k is equal to 1 is to NBR. So NBR is how many number of transmission lines are available. So we have three, k is equal to 1, k is equal to 2, right? Y bus is representation, Y bus of A, A is equal to, what is the formula? It is minus Y of K. Okay. Y bus NL of K, comma NR of K is equal to minus Y of K. So it is going to calculate for k is equal to 1, k is equal to 2, and k is equal to 3. If k is equal to 1, then what happens? NL of Y bus NL of 1. What is NL of 1? This is the first one. What is NR of 1? This one is equal to, that means it is calculating capital Y12. Capital Y12 is equal to minus of Y of 1. So Y of 1 is the admittance of the first element. So what is the first element admittance? From this it is going to calculate. So that value will be represented here. That indicates capital Y12. Okay. Similarly, if k is equal to 2, what happens if k is equal to 2? NL of 2. So what is NL of 2? 1. What is NR of 2? 3. So again it is going to calculate minus Y of 2. That means second element admittance value. This one, second one. So similarly, third one. So if k is equal to 3, what happens here? NL of 3, comma NR of 3. What is NL of 3? 2. What is NR of 3? The third one, 3. So that means it is calculating Y23 is equal to minus Y of the third element admittance value. That is, this is the third element. Okay, so this is the way how it is going to calculate the off diagonal elements. Okay, and NBR we have stopped up to 3 because we have only 3 transmission lines, and the length of it, how many transmission lines we have? 3. So therefore it is going to stop up to 3. So for example, if you want Y12 is equal to Y21, then we are going to write like this. This NR of K, comma L of K, close the brackets, is equal to the same thing. That is Y the same value, because capital Y12 is equal to capital Y21. NL of K. So if you are calculating Y12 here, then it is going to calculate Y21 is also equal to Y12. Okay. So for that reason we have represented here. So then after one loop is completed for the off diagonal elements of. Now we will jump to the formation of diagonal elements. Formation of diagonal. We will start with first, and this time we require number of buses. So n is equal to 1 is to n bus, semicolon, then after unit of semicolon, then after again we require for k is equal to 1 is to, similarly how we have written previously, NBR. Okay, so this also doesn't require any semicolon. We have a condition here. What is the condition? If this is not off diagonal, we need to decide which one is diagonal, which one is not off diagonal. If we need to verify NL of K L of K is equal to N of plus, then it will state, if this condition is satisfied, then it is going to calculate Y bus n comma n. Y bus n comma n. Y bus n comma n is nothing but than capital Y11, capital Y22, capital Y33 is equal to same thing, Y bus n comma n plus y of k. Capital Y bus of n comma n is equal to y bus of n comma n plus y of k. For example, if n is equal to 1 and for k is equal to 1. So what happens? NL of 1 is 1 or not? We need to check. Is NL of 1 is 1 or not? Yes, NL of 1 is 1. So if it is yes, then it is going to calculate y bus 1 comma 1 is equal to y bus 1 comma 1 plus y of 1. Okay, the previous y bus 1 comma 1 is not there, so it will be 0. Then what happens again? Again, what it is going to take place is it will move from k is equal to 2. If k is equal to 2, then what is going to happen? I will explain by using the concept. So how it is going to be done means, so first of all, in case of this one, I think it is clear about this one, right? So we'll try to understand this one. So how we are going to understand this one? For n is to 1 bus, that means n is equal to 1 is to, what is the length? 3. And what is the k? K is equal to 1 is to, what is the NBR? 3. So n bus is also 3, this one is also 3. So first I will do for the first, that means n is equal to 1, okay, and k is equal to 1. So what happens if k is equal to 1? Then it is going to verify that is NL of k is n or not. That means is NL of k is 1 or not. Yes, it is 1. If you see clearly, it is 1. Then if it is 1, then it is going to calculate y bus of 1 comma 1 is equal to y bus of 1 comma 1 plus y of 1. So y of 1 value we already know. There is a first admittance value element. Okay, so it is going to do this one. So now you are going to get y bus of 1 comma 1 is equal to y of 1, because we don't have the previous element here. We don't have any y bus of 1 comma 1. So k is equal to 1 calculation completed. Now what it is going to do is it will calculate for k is equal to 2. Then after it will do for k is equal to 2. So in case of k is equal to 2, it will verify is NL of 2 is equal to 1 or not. Is NL of 2 is 1? Yes, it is 1. So again it is going to calculate y bus of n comma n is 1 comma 1. So this n is not changing, only the k is changing first. Then after y bus of 1 comma 1 plus y of 2, because k is equal to 2. So then what happens? This y bus of 1 comma 1 is equal to y bus of 1 comma 1. We already there here. That is y of 1 plus y of 2. Again, after calculating this one, it will do for k is equal to 3. So for k is equal to 3, it will verify is NL of 3 is equal to 1 or not. It will verify either it is NL of 3 is 1 or not. No, it is not 1. So if it is not 1, then it will move to the else condition. Else condition, and it will verify either NR of 3 is 1 or not. See here, it will verify either NR of 3 is 1 or not. Is NR of 3 is 1? No, it is not 1. So it is also not 1 means what happens? It is going to calculate the y bus lastly as end. That means therefore y bus 1 comma 1 is y of 1 plus y of 2. That's it. So this one will be your y11. So it has calculated for y11. Next what happens? It will move for n is equal to 2. Again it will do for n is equal to 2. Again it will do for n is equal to 2, and in this case again k is equal to 1, k is equal to 2, k is equal to 3. In this one again it will verify either NL of 1 is equal to 2 or not. Is NL of 1 is equal to 2? No. And if it is else means it will verify either NR of 1 is 2 or not. It will verify yes, NR of 1 is equal to 2. Then it will calculate y bus of 2 comma 2 is equal to y bus of 2 comma 2 plus y of k. What is k? 1. Okay, therefore y bus of 2 comma 2 is equal to y of 1. Okay, so after that one, after completion of this k is equal to 1, it will do again for k is equal to 2. We are going to calculate again for k is equal to 2. That means it will verify either NL of 2 is equal to 2 or not. Either NL of 2 is equal to 2 or not. No. Then what you is else it will move to the next step and it will verify either NR of 2 is equal to 2 or not. Yes, NR of 2 is also not equal to 2. So it is also not equal to 2. Then this one will be your y bus 2 comma 2. So it is not going to do anything in k is equal to 2. It will move to the k is equal to 3. And again at k is equal to 3, it will verify either NL of 3 is equal to 2 or not. NL of 3 is equal to 2 or not. NL of 3 is equal to 2. Yes, it is 2. If it is 2, then it will start calculating y bus of 2 comma 2 is equal to y bus of 2 comma 2 plus y of, what is that element? 3. So y bus of 2 comma 2 is already there here, y of 1, that means y of 1 plus y of 3. So this is the way how it is going to calculate. So this is the way how actually the y bus is going to calculate by using the program. So we have written only if else condition. So this is for n is equal to 2. Similarly, the same thing we have been able to do for n is equal to 3. For k is equal to 1, for k is equal to 2, and for k is equal to 3. So it is going to calculate y bus 3 comma 3. Okay. So I will write also for else condition. Null is not satisfying, it should need to satisfy at least nr, that is nr of k is equal to nr not. So if it is yes, then calculate y bus of n comma n comma equal to y bus of n plus y of k plus y of k. Give a semicolon. End this program if and else. If these two are also not satisfying, else end this one and also end this one. So now if you see clearly, all the programs have been, all the loops have been ended now. So for end, here also for respect to end, for respect to end, if and else end. Okay. So this is the way how we need to write the program for formation of. We are going to calculate the off diagonal elements. We are going to calculate the diagonal elements. Now let us run this program and verify that are we getting the same result as theoretical calculation or not. Okay. So in order to run the program, go to the editor option. First of all, save the program. So which I have already done that one. So just save the program and click on run button. So change folder. So we have error. So obviously errors will come, so that we are going to verify that where is actually a mistake. So you can write here actually here if else and here else if. So we need to get this one, because if you write else if, then only it is going to get closed completely. So now see if you run now this time, yes, now the error is cleared. So in the command window, it will show you the name of the file. Okay, then it will not get the result by itself. You need to by bus and press enter. So it will show you the result. This is the result of y bus. Program what we have written. We'll verify this result with theoretical one. So where is theoretical result? This is the theoretical. Now we'll start verifying. So what is capital Y11? See here 0.98 minus J 3.91. So it is 0.98, 3.91. So it is approximately same. Next. So this one minus 0.392 plus J 1.56 minus 0.392 plus J 1.56, correct? And Y13 is 0.588 plus J 2.35, 0.588 plus J 2.35. Okay. Similarly here also capital Y21 minus 0.392 plus J 1.56, correct? And 1.5686 minus J 6.27, J is also correct. And Y23 is equal to minus 1.176 plus J 4.70 minus 1.176 plus J 4.70 is also correct. So verify also for the third column, for the third bus. So Y31 is minus 0.588 plus J 2.35. So this one is also correct. And minus 1.176 plus J 4.70 is also correct. 1.764 minus J 7.05. 1.764 minus J 7.05. So all the values we have done theoretically, it is matching. So the practical values are matching perfectly with the theoretical values. Okay. So this is the way how we are going to do it theoretically as practically in order to form the Y bus. Thank you so much for listening this session.